leave everything here, and this example is exactly to exercise this. So we are given epsilon x prime equal to 14.6 and in the unit of GPA, and all the Young's modulus are in GPA 3.5, and gxy prime equal to 4.2. Also mu x prime y prime equal to 0.4, mu y prime x prime equal to 0.1. So you see, for this case, a little bit different. We are given the information for C2. Okay, so for exercise, we are given, we can do the reverse process. And however, for this case, we also given the sigma stress equal to minus 3.5, and in the unit of MPa, and sigma y equal to 7, and then tau xy equal to minus 1.4. And the exercise, I mix everything. I won't give you all the information from one side. Okay. And we're going to find, to calculate, is the epsilon x, epsilon y, epsilon xy. So we see. So from here, we can see what information are given, what information we're looking for. So to be careful. So let me highlight the information given. So this one, C2 is given. Okay. And then those are given. Okay. So what we're looking for, this. Oops. Okay. So that is the information, and that's the reason I keep those things, and we see. So right now, if we want to, so here you see, basically that is the thinking process. If we want to find this value, then we have to know the C0, right? If we know this matrix, then simply multiply with this one, we got this one. But we don't know C0, right? How can we calculate C0? Any idea?
Well, we know C2,
yeah.
So you can derive from that.
Yeah, exactly. So that is the key, right? So basically, with everything in place, we know the C0 is this one. So the calculation is pretty straightforward. If we simply put into matrix, into MATLAB, and then multiply the three matrices, we're done, right? And what is T? For this case, the T, I forgot one piece of information. For here, I forgot to give you the theta equal to 60 degrees. Sorry. Okay, we need this information to calculate T. So for this case, we know the T matrix at 60 degrees, and that one we can determine quickly. And T will be equal to 1/4 and 3/4 and square 3 over 2 and 4. Okay, so T matrix is given here. So directly plugging into there, then we done everything. Okay. So this is the simple example. And one note I want to mention to you, for calculating the inverse of this one, to calculate the inverse of the T, because T is not symmetric, so to calculate inverse, you have to do it manually or do it in MATLAB, okay? And it wouldn't be, because T is not symmetric, so that means T inverse is not equal to T transpose. No, that is the one I want to mention to you. And given those things, and then I want to give you a note. So that is the first question. The second question is this. If we would vary the value of theta, I will ask you to do the parametric study. Okay, for example, I designate the theta is vary from 0 to 45 degrees. Okay, and then I will ask you to say, for example, give me a plot of the Young's modulus EX as a function of theta, plot EY as a function of theta, plot is a theta, EX, and plot theta as a EY, and plot the theta as a new XY, and then the new YX, etc. Okay, so somehow the curve will be something like, I don't know. Then to answer these questions, I believe I tried to design a homoprovince and ask you to do the kind of a laborious exercise, okay, to reinforce the concepts. So for that regard, I've been very kind. Here is a handout to do the double print handout, and for you and for John. So this handout is a double print page, and then to answer the questions, I believe either you need to express these components in terms of function of theta, or you have to explicitly express this 9 components. 9 components, basically just symmetric, I would say 6 components as a function of theta. And to do that one, do the manual calculation unless you have a Mathematica, and that's the software for symbolic calculation. Otherwise, you have to do the derivation by hand. Okay, and the second handout, the page, on the second page of the handout, I have done the dirty work for you. Okay, so which means to plot those things, you simply verify my calculations and then plot each component in terms of this one. Okay. So you can try is using the functions I derived, plot the curve. On the other side, in MATLAB, you use the for loop for, say, theta equal to from 0 degrees and incremental, say, 0.5 degree until whatever the range, say, 45 degrees. You do the calculations, then you obtain the values for those components. Then you plot, for example, when theta equal to 0, you have the point here. When theta proceeds to 0.5 degrees, you have point here. Then etc. Then once you have so many points, you simply trace the curve. Compare the curve with the symbolic calculation of my work. Okay, I believe my work should be right because I kept my scratch papers here. But that could be the one, and to reinforce your exercise of the things. Okay. So Max, we've done this section here.